Remember, the difference of two perfect squares is the sum and difference of each of those factors that are being squared. So this is really a tool that we're going to use to rationalize denominators or numerators that have more than one term. So these two factors, a plus b, a minus b, those are called conjugates of each other because they have the same terms with a different sign. And when rationalizing an expression with two terms, we're going to multiply by the conjugate of that denominator. So say in your denominator you have root x minus 1. Then we're going to multiply by root x plus 1 to both the numerator and the denominator to rationalize, because that is going to get rid of the radical here. So we'll see samples. Rationalize each two-term denominator. So for a, the first thing, again, always make sure that if you can simplify, to simplify first. And then if you can't, the second step is to go ahead and multiply the conjugate to both the numerator and the denominator, and then simplify if you can and get rid of any parentheses. So in this case, I don't see anything that can be simplified. The radical is as simple as it gets. There's no factors I can divide, so I'm going to go ahead and multiply by the conjugate. So 2 root 5 is the first term, and I'm going to change the addition to subtraction, 1. And I need to multiply the same thing to the numerator as well, because then I'm not changing the value of the expression. So in the numerator, I'm just going to leave, I'm not going to distribute yet because I might be able to simplify. So I'm going to leave it as parentheses here. But in the denominator, I definitely want to multiply. So I know that the conjugate is going to leave me the first term squared minus the second term squared. So the first term here is 2 root 5. And the second term is 1. Okay. So don't change anything in the numerator yet. Let's go ahead and square these. So this is actually going to be a product 2 powers. So first 2 squared and then root 5 squared. So let me just simplify over here. So 2 squared is 4. And if I square the square root, then that cancels. And that's 4 times 5, which is 20. And then 1 squared, that's easier. That's just 1. So 20 minus 1 is 19. And it's at this point when I say, can I divide these factors? In this case, no, they don't share any factors. So I'm going to go ahead and distribute then. This 3 is not in a radical, so it stays in the front, outside of the radical. So 3 times 2 is 6 times root 5. And 3 times negative 1 is minus 3. And that rationalized the denominator there. For b, I want to look and see if I can simplify first. And there's nothing to simplify. So now I'm going to multiply by the conjugate. The square root of 3 plus the square root of 2. Need to multiply the same thing to the numerator. And so in the numerator, well, when I multiply a 1, that's not going to change anything. So I'm not going to leave that 1 outside. If I were to distribute, that doesn't change the root 3 plus the root 2. It's an identity in multiplication. Now for the denominator, I'm going to do the first term squared minus the second term squared anytime I multiply by a conjugate. So the first term is root 3 and the second term is root 2. Awesome. Now I'm going to actually square those in the denominator. So root 3 squared is 3 and root 2 squared is 2. So when I subtract, that's just 1. And I don't need to divide by 1, right? So I'm just going to erase that. And that's my rationalized expression. Example C. Let's see if I can simplify anything here. Nope, can't divide, so radicals are already simple. I'm going to multiply by the conjugate. So 2 plus root x is the conjugate of the denominator. Multiply that to both. So in the numerator, I'm not going to distribute yet because it's possible that I can simplify after I rationalize. So I'm just going to leave that. And then in the denominator, that's going to be the first term squared minus the second term squared. So first term is 2, and the second term is root x. Okay. I'm not going to change anything in the numerator yet. Let's see what we can do in the denominator. 2 squared is 4. And root x squared cancels out, leaving x, again, assuming positive real numbers only. So now, can I simplify by dividing any factors? Doesn't look like it, right? Doesn't look like we have any similar factors, so we can divide. So that means I need to get rid of the parentheses by distributing. So outside of the radical, 4 times 2 is 8. Inside just x for the first term. Multiply the second term. Outside is 4. Inside x times x. And that x, the square root of x squared, can be simplified, so that will be 4x. And we've rationalized the denominator here.